and co-innovations, developing the people and technical competencies. He has 20 plus years of research experience in various domains such as industrial automation, building automation, automotive and safety critical, power distribution, telecommunications, networking, and data communications. On behalf of everyone, I welcome you, sir, to deliver the talk.
Thank you. So can you confirm me if you are able to see my screen?
Yes, sir,
Yes,
we
sir.
can see your
Yes, sir.
screen.
We are able to see screen, sir.
Okay, thank you so much. So good afternoon, everybody. So I understand this is the faculty development program. So I think a lot of experienced faculty here as well as young faculty. So today I will share my knowledge on the IoT and give you some perspective of the industry. What is IoT in an industry? What is IoT beyond the industry? And if you have any questions, I would like this to be very interactive. Feel free to ask me anytime any question, and feel free to address me, Mr. Viru. I have this question. Okay, so let me start. Okay, so what is IoT? Normally, when you simply go to Google and see, okay, ask Google or study any book, what is IoT? In simple terms, everybody says, every website or every book says, Internet of Things is like human beings. We are all connected to internet. We connect to internet through mobile phone. We utilize the services available on the internet. We interact with the people around us on the internet, and we consume some services. We watch movies, we chat with people, all that. So imagine a group of people interacting with the either machines or the people on internet is replaced with the things. Things are non-human, so it can be your machines, your process, or your equipment, your printer, your refrigerator, or your light, whatever things you may consider, and assume they are all interconnected through an internet, and they exchange information like we exchange. I'm talking to you, which means I'm exchanging data with you virtually, a visual data, a text data, a speech data. Similarly, the things are also interacting with each other, for a particular reason. Not only with each other, they are also providing some services, consuming some services. So that is the Internet of Things, right? So at the end, it boils down to every object should get connected directly or indirectly. Okay, so that is the Internet of Things. Um, at the same time, the Internet of Things is getting evolved, and people started calling Internet of Everything. That means it's not just objects, it's not just humans. Let's make everything connected. Okay, so it's the devices, it's the people, and connected everywhere, connected in all businesses, in all networks. So you will have a 4G network, a 2G network, a fiber optic network, an Ethernet network, a wired network, wireless network, or a, LP1 network, any network. So any network, anytime, any business, anywhere, everybody, anything. So all this, when you interconnect, that means tomorrow you are going to talk to another person, and you assume that can be a person, or that can be a machine, that can be a virtual artificial intelligent bot, or it can be a device. So it doesn't matter whether you are communicating to another person or a device. So that's the seamless interconnectivity, evolving IoT to Internet of Everything. Okay, so if you visualize the same, there are devices that gets connected. I said the devices should get connected directly or indirectly. So directly means you direct access to internet. Some having an interface with the 4G SIM card, a device can be directly connected to internet. Sometimes the device may not have such an internet connectivity directly. So let's say you have a small smartwatch. A smartwatch will not be able to connect directly to internet, but your mobile is connected to internet. So the connected devices utilize an edge device like a mobile phone. We call it as a edge device or a edge gateway. And the edge gateway give a provision to pass the information from the connected device to the internet. In the internet, to host the services, to run some applications, analytics, today we all call as a cloud, as a nomenclature. So the directly connected device will anyway connect through Wi-Fi or to GPA, 2G or 4G or 5G network, or a connected Ethernet network. Or if the device is not directly connectable, they use a nearby gateway, and we call as a edge device, and they get connected. So this is how you will visualize the Internet of Things. This is a very basic explanation of Internet of Things. Then coming to the industry scenario. Okay, you'll how do I make this can I make this uh, this bar is occupying my well, I'm not familiar to use Zoom, so pardon me. How do you pen?
I think you can minimize that, sir.
Yes, thank you. Yeah, I hide everything. Normally we use Microsoft Teams, so I'm not familiar with Zoom. Pardon me for that. Okay, shall we continue?
Yes, sir.
Okay. Hello.
Yes, sir. You
Yes,
can
sir.
continue.
Okay. So yeah, so a fully automated process or a fully automated plant, if you see. Okay. Now I'm taking to a factory. Okay, a factory producing milk packets. Okay, so what happens? You will get it can be a milk packet or a sugar, or you can consider as a cement or sugar. It doesn't matter. A fact, and there is a process defined, and there are machines, and the raw material gets converted into value added finished good, and you pack it and you will sell it in the distribution channel. And what is why do we fully automate a plant? Typically for our productivity, for scalability and consistency, which means uh, a factory which is automated and which is not automated. Not automated means every operation is done by human being. Every decision is done by human being. So when every action is a decision is made by human being, obviously there will be some delay. If I have to switch off a motor, I'll switch off, let's say every 10 minutes. I'm switching. If you see at the millisecond level or seconds level, precisely every time I will not be able to stop it. So there will be certain level of deviation. Okay, so and if I have to take decision, there will be human error, so the consistency will impact. So if a milk is produced in a factory with only human operations, every milk packet will not have precisely the same quantity of the milk, same quality of the milk in every batch, because of the human error. If you make the factory with automated, everything is controlled by a computation device, a control system, then the control system operate at milliseconds level granular precision. So everything become consistent. Every packet will have exactly the same size, quantity, quality, and it's a proposition. So the automation is for consistency and scalability. Today I'm producing 10,000 liters of milk today. Tomorrow, I want to expand capacity to 20,000 liters. Then I can simply expand it if it is fully automated. Now, why I am explaining automation and non-automation in a factory is how automation is achieved. Automation is achieved by utilizing the sensors, the actuators, and the control system, and all are interconnected. And they all connect, and the control system read the data, process is controlled. Now, if you see, it sounds quite similar to IoT. IoT, what is IoT? IoT is connecting the devices, reading the data, and doing something about the data. Okay, so you use some kind of analytics to control temperature of a building. You do some analytics to decide what should be the ambience in a hospital, or you use agricultural sensors to read the data from the agriculture and decide what should be the fertilizer applied, or how much water you need to pump in. So you all take decision based on the data you read it. Then it is exactly the same that is already happening in any factory, because in the factory you will have lot of sensors. They are all connected by a communication channel, and you read the data and you take a decision. So this is a perfect analogy for you to imagine. The IoT is not new for industrial automation. So far in industrial automation, whatever we are doing, if you take a simple architecture, a control system architecture in a process plant, it can be a food process plant or oil and gas plant. There will be a lot of field devices and the control sensors, actuators, all, and they're all connected to your control system. Typically, we call it as the programmable logic controls. And you will have the high computation PC systems or servers or data centers where you will run the engineering. Okay, and if you imagine the Internet of Things, there will be devices that are connectable. You connect, which generate some data, and you will aggregate the data with an edge device, because sometimes the sensors may not be able to directly talk to your cloud services. So you use edge device and you push the data to cloud. So if you see what exactly happens in a typical plant, a process plant, or a factory, and what is Internet of Things, both are same. So which means for a factory, Internet of Things is not new. We are doing this connecting the devices for almost more than 50 years. So what is new? There is no new. But why suddenly Internet of Things become so popular? Why suddenly we are talking about Internet of Things? It is because all these historically, all these years in the factory, we are connecting the devices. We are reading the data from the devices, from the sensors, for only the purpose of control. Control means in a given flow, the valve should open, the valve should close, the motor should on, motor should off. The object has to move this direction, that direction. You can imagine a car manufacturing plant. So the raw material come, there will be a machine that punch the holes on a plate and makes into a particular shape, and there's a machine that welds all that and make into a shape, and then you fit the tires, you fit engine, you fit all that happens with the robotic control. So you read the data, you understand the situation, you take a decision, and you perform some action. So all the connected devices, the connected data is used to generate a command to control the things. That is the main purpose. Number two, all these years we were only looking at the data for visualization. uh, Assuming we are in a sugar factory, So what is the data we have to monitor? How much sugar level or how much pH level is there? What is the color? How much is the density? And how many liters of juice is flowing? How much sugar quantum I am producing? How much RPM the centrifuge is running? So the data you will visualize. And if somewhere something goes wrong, the control engineer will take some action. Okay, is the boiler running at the right temperature or not? Is the pressure in the right level or not? So the data, one side you will use for the controlling, the another side you use for monitoring to know what is really happening. Okay, and then the third purpose is to store the data for future analysis or a regulatory compliance. Let's say simple example, you are consuming a medicine and it has an expiry date, or you are consuming a cheese and cheese has an expiry date. Suddenly one day you open the fridge and your curd tastes bad, or your milk tastes bad, or your cheese tastes bad. So what do? You will call the consumer care of the brand, say, hey, this product is smelling bad. You say, is that expiry date reached? No, it is still. That means something went wrong in the production. So that particular batch is behaving badly even before it expires. So now when you give such a complaint, what is the regulatory compliance? You have to go back and see all the data, what happened when this particular batch of a cheese is produced or a particular batch of a medicine is produced, and was there any mistake in the process? Okay, is the operator or the recipe was compromised? Is the safety norms compromised? So that there will be some investigation, and if they find, okay, this is wrong, we need to correct it. Okay, so for that they have to keep the data into archive and store it for regulatory compliance and analysis. So historically, the Internet of Things, which was so far in the industrial automation, is meant for only three purposes: control, monitoring, and visualization. Control, monitoring, and regulatory compliance only. But now there are two technologies suddenly come into the reality that is changing the perspective. Number one is the cloud. Number two, the mobile devices or mobility. The cloud is making uh, available to every person with no cost. Today, you want to set up a database in the cloud, you can simply subscribe and keep it. You don't need a big data center. You don't need a big server. You want to develop a web application, you can subscribe and do it. So the cloud enabled the data storage, the application development, and the computation power. If you want one CPU, 10 CPUs, or hundreds of CPUs, you will get it just by configuration. You just need to pay. So you don't need to buy all of them upfront. So because it's a pay-per-use model. So the cloud technology made easy to develop the web application, to develop the web-based services, and any scalable computation power. So this is one technology that made Internet of Things so popular. Second is that mobile device. The mobile device, everybody can have access to the information from their fingertips, and the mobile platforms gives you to develop any kind of application which is easy to use with scalable software. So you can port it. So this makes consumption so easy. Earlier days, you just need to a laptop with so much connectivity and so much of firewalls or cybersecurity things. Then only you will be able to start consuming the services. But from your mobile, in the name of an app, or in the name of a browser application, or in the name of the push notification, you can simply consume the data, consume the services. So one side, cloud is enabling to gather the data, to analyze the data, to develop the applications and analytics on this data, so that you get value out of it. In the historic, all the 50 years, the data is only inside a plant. inside a factory. The IoT architecture is there, but the data is there, and data purpose, as I said, only for controlling, monitoring, and storage. But if I want to run analytics of on top of this data, the amount of computation power required was very limited in the factories. But once I have a technology like a cloud, now I can take this data and put it in the cloud, and I can run plenty of analytics because I have plenty of computation power available. And historically in the factories, probably we will have capacities to store data for 1 year or a 1 day or 1 month, depend on the regulatory compliance. A tablet making company, when you put a tablet in the market, you need to keep the data for 3 years because the expiry date is 3 years. If you are in a milk making factory, a milk expiry date is 2 days only. So it's okay to keep data only for 2 days. Third day you can flush and start storing a new data. So the amount of data to be stored based on the regulatory compliance, based on the product. So you will always have a fixed amount of computation. You have scalable and analytic services you can consume with the data you provide with the data and provide. And when you provide, you need to be inside the factory. You need to connect to inside the factory network. Then only you will be able to see it. But today, a plant manager can see the production status sitting at his home, looking at his mobile or a tablet, because the tablet and mobile are now connected to the cloud. Thanks to these cloud technologies, he don't need to sit in the factory to look at the status. Suddenly there is a 24/7 operations in a factory, and the boiler is working in a steel plant, and I don't need to be in the factory 24/7 to look at the whether boiler is in right condition or not. Is there any failure is going to happen, a blow up is going to happen, so I need to consistently monitor. No, you don't need with this. So you use the mobile and cloud services, and if something goes wrong, you will get a notification. Open the situation on your tablet, wherever you are. You don't need to be in India, you don't need to be in the same country, because you are connected on the internet across the globe. So this is the power of the mobility and the cloud. That is where the internet of things started becoming popular. Otherwise, there absolutely nothing new in the architecture of the industry, internet of things in the industry already. Okay, so now with this emerging internet of things, it started going outside the factory. Now can we use the same concept in the residential buildings? Can we use the same connected things in the commercial buildings? Can we use the same internet of things in the hospitals, in the airports, in the universities, in the agriculture, everywhere? So now the internet of things exploded and connected everywhere. So take a simple example of a building. You want to put temperature sensors in a building and collect the data and make some analysis. You want to put some smoke sensors in a building, analyze, collect the data, analyze and tell whether the hazardous conditions are there in the commercial building or not. Or you put certain sensors, some data from the hospitals, and see whether the right hygiene conditions are there in the hospital, and how can we improve. So the data can be from any source. It can be from energy meters, it can be from the smoke detect sensors, or it can be temperature sensors, or it can be equipment can generate data today. And you collect this data and apply some analytics and make some meaningful insights. So that's where the IoT is evolving and penetrating. So that's all about the how IoT and what exactly is the new in IoT in the industry. Okay, let me go to the next slide. So far, any questions? Okay, so no questions. Then let me go to the future. So how
Sir, we
that
will be, excuse me,
industry?
sir. Sir, we will be
Yes, please.
taking questions at the end of the session through the chat box.
Okay,
Now, participants are
sure.
requested to post their questions in the chat box. We will be taking that and asking at the end of the session, sir.
Okay,
Yeah, thank you.
sure, sure. So so
Hi,
far,
Leo.
thank you so much. So okay, so far I explained the principles of IoT and what is IoT, how it originated, and what is the difference in the industry. Okay, and now how the now the industry is changing, and how IoT will change the way industry operate. Okay, the IoT is coming from the industry. I just explained because it's already there from past 50 years. There's nothing new in the industry IoT. At the same time, the IoT evolution, the IoT concepts coming back and influencing the manufacturing industry and completely disrupting the way they are going to operate. And we all know people are talking about when we are talking about IoT or IoT, it is linked to the industry 4.0. What is industry 4.0? The first industry happened with the steam engines, where a lot of heavy duty operations are simplified with the steam engine. With the invention of steam engine, we will be able to push a heavy vehicle like a train, or we can pump water, or we can move items in a factory with the engines. So the steam engine made manpower augmented with the machine power. Then the steam engines are replaced with electrical engines. So electrical engines are far more efficient, far more faster. So the next second revolution happened in the industry with the introduction of electricity inside the factory with electrical motors and electrical controls. Then uh, not only they simplify the human work, but the production rate increased. They were able to produce more items in short time. Okay, now after some time in the industries, the computers started coming inside and people started using computer based control. The decisions are by the computers, not by the human being. Now obviously what happens when the computer started taking the control, the accuracy will improve, the quality will improve, and the scalability will improve. Now that is the third industry revolution, which is what today we are in. All the factories today, they're all controlled with the computer based decisions. Of course there is an operator, but the control system is using a microprocessor or microcontroller or a system on chip, which is a computer based algorithms to run, to decide, to control the robots, to control the process, to control the machines. So we are right now in the third generation of the industry, and we are going towards the fourth generation of the industry, where all these computer controlled physical machines are interconnected. They become the things of the internet. Okay, so they all interconnect, most likely wirelessly. Of course, it doesn't have to be only wireless, it can also be wired. So all the machines in a factory gets interconnected, and you don't need to go to factory to control them. Today, you cannot imagine a tire producing factory or a vehicle producing factory or a sugar producing factory without human beings, because though the systems are controlled by computers, you still need operators, you still need engineers, you still need maintenance people, you still need electricians. So any factory you go today, there are a lot of people, because the certain crucial interaction decision has to be still taken by the people. Okay, and so you cannot imagine today, but tomorrow, assuming all these machines in a factory, they are intelligent, okay, and augmented with the artificial intelligence, and they are all connected, like humans connected to the internet. They all connected to the internet. Then the operator don't have to go to the factory. If he want to control a process sitting from home, he can do it. If an automation engineer want to do some modifications in the production plant, he can sit at home and monitor, and he can operate from home. So in the fourth generation of industry, there will not be any operator necessary to be in the factory. It's completely manless production factory. So that's what fourth generation of industry, that's called industry 4.0. To understand how much time you are giving for question answer, so that I can adapt my speed and try to give sufficient time for questions. Now it's 2:08. So what time we stop for question and answers?
Yeah, we can stop at 2:45 and then take question answers.
Sure, sure. So we are okay. So now, so what is, how do we understand Industry 4.0, what it is? So for you to easy to imagine and easy to understand Industry 4.0, the fundamental concept, there is a movie in the recent years we have seen called Avatar, right? I am assuming most of you have seen Avatar. If not, I encourage you to see it once, because this triggers your thought process and try to understand. So what is the fundamental concept in Avatar? There is a physical man, okay? A person goes into a chamber in this, and he connects his brain to another person. Okay, left side what you see is avatar of this person. Okay, it's physically a different equally capable person, but he doesn't have his own brain. His brain is operated by this person's brain who goes into this chamber. So which means what you see left side, what we call avatar, is like a virtual identity of this physical device or physical person, a real person. So avatar is nothing but the virtual another twin personality of the real person. So that is the concept. Exactly the same concept has been applied, are going to be applied in Industry 4.0. So in Industry 4.0, there will be a physical set of devices. Okay, these devices can be a machine, can be a process, or can be a small motor, or it can be one sensor. Any physical item you can think of. It can be a fridge, it's a oven, it's a motor, or it's a boiler, or it's a milling machine, or it's a CNC machine, or it's a packing machine, or it's a refinery. You consider any physical asset. Okay, so that is will be represented with a digital version of the physical asset called digital twin or a cyber twin. So every physical device will have equivalent digital presence. So whatever the physical device do, virtually the virtual device also do. But why do we need both? For example, I want to monitor the real data of this physical device. Today, the operator is going to the particular machine and see on the screen what is the data. And assume this has a virtual presence in the cloud, and everything what this data produced from this physical device is up to date on this virtual. Then this is accessible everywhere. You go to home and you open the virtual device of a physical device and look at it. You get the data, the status of this machine. And let's say you want to stop this machine, you can stop it from virtually. You want to configure, assume this is a packing machine in a factory, and today I configure it to pack 1 liter milk packet, and it started packing 1 liter milk. And tomorrow the order changed for the factory. Now this packing machine has to pack not the milk but the cheese. So he reprogram this machine and say, okay, now onwards you pack the cheese, but not 1 liter, half liter, or 500 grams of cheese. So the machine organizes itself to start packing the cheese half liter. And day after tomorrow, you reconfigure this device and say, okay, now we have a new order. We have to start packing the ghee. So you pack 2 liters of ghee. So it will organize itself to pack 2 liters of ghee. So for that, do you really need to go to this machine in the factory and do it? Not necessary, because you created a virtual device, and through virtual device you can configure. By configuring virtually on the cloud, the configuration gets affected in the real physical device, because they both are completely synchronized. Okay. And what if for example, if this device is having some trouble, you are getting alarms, and you want to troubleshoot, you really don't need to go to the physical device. You can connect to the virtual device and open every part of it virtually and see where is the problem. Is the gearbox damaged? Is the electricity connection damaged, or some sensors damaged? You can realize. But the physical replacement you cannot do virtually. You understood the problem, you solved it, then you really need to go to the factory and change it, because that's a manual activity. Other than that, configuration, monitoring, controlling everything, whatever you can do physically in presence to a machine, you can do it exactly the same on your virtual device. So when you like that, the entire factory is some of the machines. In a factory, you have a raw material coming in, and raw material is getting processed with the different machines, and finally you get a finished good, and that gets packed and delivered. So a factory is nothing but a sum of machines, and each machine has an operator. So when you virtualize this entire factory, the virtual factory is some of virtual digital twins. So the people, the operators, don't have to go to the factory. They sit at their own home. They open a laptop or a tablet, and they are responsible to manage a particular machine, and they just operate, they monitor, they control from them. So now this person, an operator can be in Hyderabad, an operator can be in Kochi, an operator can be in Delhi, but the factory need not be in India. Factory can be in Ukraine. Factory can be in Korea. You still work. So this completely disrupts the way the factory is going to operate. The real factory, it need not be in the same city. The real factory I set up in China, but I am operating from my home in Bangalore, or from your college. You have a big lab in the college. You don't need to be in the college to operate your lab. You operate from a remote place. So this is completely disrupting the way the manufacturing is going to happen. That is the industry 4.0. So uh, now the next step in this industry 4.0, normally we have a field devices, and we will have a control system and process control and plant management and enterprise planning. So since the machines are becoming very intelligent, assuming let's take a simple example of a car manufacturing. So car manufacturing has all the elements in the same factory, and tomorrow you say, no, I will manufacture the frame of a car in this factory, and I'll ship this frame to another factory. That's where I'll fit my engine, and then for the tires I'll fit in other city or in other place. So the manufacturing need not be in the same place, and manufacturing need not be in the end-to-end way. So you can choose the best place to get coloring is Delhi. So I will ship all my items to Delhi, and the painting happens in Delhi. Okay. And the engine fitment, the best place is, let's say, Cochin. I'll get all the engines in the Cochin. So the hierarchy of the plant is completely changing, okay, with this cyber physical systems. The next, lot of these factories, when we said the machines are augmented with artificial intelligence, with the IoT technologies, then the real white collar and blue collar sense. We used to call as white collar employees, the people sitting in the factory floor. Traditionally, we call them as blue collar employees. So the people sitting in the factory floor, but that means there is no more blue collar employee remotely to monitor, to control these machines and process. So this blue collar employee, so called, suddenly become a white collar employee, because he is not making his hands dirty, he is not wearing gloves, he is not wearing helmet anymore in the house. He just open his laptop, he connects to the machine, he operate from his. So he's as good as a software engineer. So he's a white collar employee. So there's hardly any difference. Okay. Number two, a lot of digital workforce will come into the industry. Okay. Digital workforce means the Autobots, the bots who makes the parts move, the bots who takes decisions, the artificial intelligence built into the some of the repeated tasks. So when the digital workforce come, which is completely virtual, then there will not be any strikes in the factories. There will not be any human capital issues in the factory. So there will be a huge and they don't demand salaries, they don't demand salary hikes. So there will be a huge transformation in the workforce planning of a factory with these IoT technologies. Okay. So then the change in the business model. Okay. Then example, I'm not sure how many of you are aware of Airbnb. Airbnb is a company where they don't own any hotel. What they do is that they will convert a house into a hotel temporarily, and you can go and use. Okay, today I'm using your bedroom as a hotel room. I come and I'll sleep for one night, and I pay some money and go. So you are not converting your house into a hotel, but you are just offering. Just a paradigm shift happened in the hotel industry. So which means it's just a service. Okay. So similarly, with the industry 4.0, with this IoT enabled technologies, anybody can open a small factory, and they don't need a full production end to end. So you say, okay, my factory is available. Anybody can use it, the service. So a person sitting in Germany, he need a printing services, or he needs some forging services. He will search, okay, in the world where are the forging machines are available, and he will lease it, or he will book it, and he use that forging machine. And the machine may be in Chennai or in Bangalore or in Kolkata. They don't worry. So they use that particular machine for particular time and the service, and they release it, because you don't need physically present in that factory. So an engineer in Germany can use a service of a machine available anywhere in the world. That is a new business model. And the another business model, you may worry how a person sitting in Germany is making a product in Kolkata, because the machine is available in Kolkata. How will we ship this item from Kolkata to Germany? Okay. So that is not practical today, but the trend is going that way. Simple example: today you want to buy a mobile phone, you don't go to a shop anymore. You browse on the Amazon or Flipkart or websites like that. You buy it. Do you really worry whether the mobile is coming a shop next to your house, or the mobile is coming from a store in Bangalore, or the mobile is coming from Delhi? Do you really worry? You really don't worry. You really don't know. Okay, you really don't care, because the Amazon will take care of seamless exchange of these goods and logistics. You are buying, you just need to search, okay, I want I want a home decor. Maybe this home decor is made in Assam. Okay, there is a vendor in Assam. You really don't have to worry, how do I get a home decor from Assam to my home in Bangalore? You really don't worry. You just go to Amazon, you search that item, you pay it, and Amazon will take care of bringing that here. Okay, so with the transformation happening in the logistics and the connected supply chain with the optimization algorithms, it doesn't matter a particular product is made in Bangalore, but ship it to Chennai or ship it to Berlin. It doesn't matter. The logistic is so intelligent. The systems will be so intelligent. It will take care. So this is called collaborative automation. So if I want to make one laptop, and laptop has several parts, and all the parts need not be in the same factory like today. These multiple parts can be manufactured in different parts of the world. I can still assemble and make a final piece. So that is the vision, and that's how the future will be. Okay, so at the end, everything gets connected. So the factories get connected, the logistics get connected, the people get connected, the transportation gets connected, because the logistic means including the transport, and the cities gets connected, the city infrastructure gets connected in the name of smart homes, smart transportation. So at the end, everything, internet of everything will happen. So with that, what is the benefit of doing it? So today, you want to order a particular recipe of a Coke, you cannot do it. You want to buy a phone by let's say Nokia or an iPhone. uh, They in the name of economy of scale, or in the name of large scale manufacturing, they cannot customize a one phone for you. If you want to buy a laptop, you go to Lenovo, and Lenovo is giving a black laptop, but you want a red laptop. They don't manufacture one laptop for you because it's not viable. Or you want to order a car, but you want to customize your car. You go to Volkswagen or you go to Maruti and say, hey, you know what? I want a car with these features. They cannot manufacture for you alone, because making one car is very, very expensive. If they make all the cars the same millions, then they save money. But with this collaborative automation, with this new industry 4.0, you can personalize everything you want. You can personalize your car, you can personalize your Coke, you can personalize your laptop, you can personalize your own clothes, you can personalize your pen, everything with the same economy of scale, and you will get it. Okay, so soon, the summary is that sooner or later you will personalize, and you get your you can personalize your shoes, you can personalize your cell phone, and you order and you get it. Okay, so you don't need to worry about it. So that's the power of industry 4.0. Okay, now I have 20 more minutes to give you certain opportunities, because you are all faculty, right? And you are from universities. You will have a lot of opportunities to discover the issues in the local ecosystem, in the Indian ecosystem, and what are the research opportunities you can think of, and how can you use the IoT technologies to solve some of the problems, and shape the future of this country, or the shape the future of this society. So what are the things that you can look at it from my perspective? Okay, let me give you one example. In India, so far the story I narrated is very much relevant for fully automated plants. Okay, in India, we still do not have fully automated plants everywhere. Okay, uh, if you take a bigger brands like a Nestle or Cargill or Mondelez, or you take Britannia or Parley, or you take a bigger brands like Lenovo, or in the food industry, Amul, these kind of bigger brands, they are completely running with full automation because they are at large scale. But if you go to in your town nearest milk processing plant, probably they are still working with a lot of workforce. If you go to a small bakery nearby, maybe they are all with manual power. Okay, or you go to nearby rice milling machine, you will not see automation. Still, the operators are working in the rice mill. Or maybe in your area, coconut grating or coconut oil may be more famous. Go and see, the machines are there, but still people are operating. They are not fully automated. The story I narrated so far is very much relevant for the fully industrialized, fully automated factories. But it is far away from most of the factories in India. They are neither automated fully nor semi-automated. That means 50% automated, 50% I rely on the human operation. So what is the challenges? The productivity is a challenge because the efficiency of operation depend on the person's knowledge and how fast he can react. And with the changing society structure and the social preferences, it's very difficult to get skilled people. Okay, and you recruit a person, he stay, and after 1 year he will find a better job and he move on. Now you don't have a person to manage your production, so you recruit another person, you train him. But will that new person get training within that time, or he will be productive and same time? You don't know. So productivity is a big challenge, and the old people, experienced people who are retiring, and the new people are not interested to come and take these jobs. Okay, so productivity is a problem. Consistency. You have 2 3 production lines in a factory, and each line is operated by a group of people. It's humanly impossible that everybody do exactly the same. It's impossible humanly. Okay, so the consistency, you take a simple bread packet, you go to a nearby bakery and take 2 bread packets and observe them. They will not be same, they will not have same size bread slices inside because it's made by human being. But if you go to a factory made, everything will same because it's a machine made. So the consistency of operation, consistency of the product, consistency of things is a challenge with when it is a human operated. And safety and the scalability. Um, Obviously, when the things are operated with people, there are people safety issues and process safety issues. Food and beverage, especially, is consuming, right? Any negligence will cause a bad quality food, and that will affect the human safety. We all consume. If assume if your milk packet and you are opening and milk, and suddenly you tasted sour, we don't know what went inside the milk. Okay, and scalability. Suddenly I want to increase the production. Okay, there's a festive season, I want to produce 1 more million liters of milk because tomorrow Pongal coming, or some festival in your area is coming. You cannot do it because with humans you cannot overnight scale it up. Okay, and the efficiency and optimization is obviously a challenge, because the efficiency of a people will change with time. It's not like a machines. Okay, optimization is related to waste. So you will find more wastage, and either wastage of the time, wastage of the raw material, or wastage of the finished goods, wastage of the packing. If the humans are involved, because of the natural challenges of a human being, these challenges most of the factories are facing. But can they completely automate overnight? No, they still running with these challenges because the completely automating a factory is heavily capital intensive. They need to invest huge money, and they want to still retain the workforce. They want to give the jobs. They don't want to kill it. So their good intentions are there, but these inherent challenges are there to solve. So how these challenges can be solved? So let me hide this. Okay, so in a factory, if you start researching, if you start thinking and making some experiments, can I use the IoT technologies? Can I club this IoT technology with artificial intelligence and help these semi-automated or not automated machines to solve these problems? can you guys come up with, okay, in a factory where it's completely machines, but I want to use some low cost IoT sensors, low cost IoT devices, and having a mobile phone, having a edge device, having a cloud is not so expensive. Okay, so that is the advantage, because you go and buy a temperature sensor, it is not expensive today, because the of the IoT popularity, there are many companies producing lot of smart sensors. Okay, and simple Raspberry Pi, you can use it as an edge device. Okay, and Android phones are there, very low cost Android phones today we can get even at 5 6,000 rupees, a basic Android phone, or less than 10,000 meaningful Android phone you get it, which runs with 3 to 4 GB of RAM, and 1.2 to 2 gigahertz clock speed, and huge computation power you already have, and a cloud subscription, a very cheap cloud subscription. And with all these technologies, and put some artificial intelligence, and come up with some innovative ideas to solve those challenges I mentioned in the factories, and then they get benefit of it. Okay, so this is one area where universities in India, because these problems exist in India, you go to Europe, these problems will not exist in Europe, so they don't even understand these problems. But in India we have these problems in every corner. Okay, if you go to any nearest factory, you will get hundreds of these challenges, and here you can start thinking how to apply the your IoT knowledge and IoT system, and start solving some of the problems. Okay, so what is the benefit of solving these? Obviously you will improve the consistency, you will improve the quality of the goods that we produce. Okay, the quality of the food that we produce, quality of the material that we produce, anything. Okay, obviously we give safety. You put some IoT sensors in the factory, and suddenly you see, okay, here the carbon dioxide gas is coming more. You put some sensor and put some alarms, and give notification to his mobile, and the operator will not go there, and he is safe. Otherwise he breathe the carbon dioxide, and he cannot actually make any sense, because carbon dioxide doesn't have any smell. Okay, he breathe it and he will faint. So this is the problem. Okay, so this simple problem can be solved, and you put some sensors, some temperature sensors or fire detecting sensors, and say, hey, don't go this area, I think there is a chance of getting fire, so don't go there. So you are saving a life of the people, and you apply some predictive analytics and say, okay, I think tomorrow you will have a predicted problem, and prepare them. So there is no limit to come up with a number of ideas. The only thing is that understand the challenges in the ground level, and use these technologies to come up with the simple solutions, so that the operators can get the a lot of support on their mobiles, the production can be improved, and you will save the lives of the people. At the end, it all sums up to the efficiency optimization. A simple example, you read the energy consumption data of each machine and each operation, and come up, okay, this factory is consuming 100 kilowatt hour in a day, but in another line or in another factory, you find only 80 kilowatt per hour day. Then if you put simple analytics and say, why this factory, or why this person, or why this machine is taking more energy compared to other, something is wrong. So let's see why it is, and can we save 20 kilowatt hour energy here, can we optimize it? Let's optimize it. So far it is not done, because it's not connected, nobody is reading the energy meters data and analyzing it. They get a bill and they pay it, and they worry every time why I'm getting a heavy electricity bill. But nobody is studying how much current leakage is happening, how much time the machine is kept idle and unnecessarily wasting the energy, how much time the operator is not present and he went for a coffee and he forgot to optimize the machine. There are plenty of things that we can optimize, and bring back some profitability to our Indian factories. Okay, so these are the some of the examples I say. Okay, and let's say you will observe, India is a rich country with a lot of food and lot of food transportation, but at the same time we are wasting a lot of food because we are not able to preserve it. Okay, at the same time lot of food is getting adulterated. Okay, can we apply some intelligence? Can we apply the IoT technologies to assess is the food during the transport getting spoiled or not? Is the food is it still intact or not? Okay, is there any food adulteration happening in between or not? You just need some sensors to collect the data, analyze it, and give right information to the right stakeholders, and so that in between the food will not be tampered, the food will not be corrupted, the food will not be adulterated. Okay, so these are the some examples where it only happens in India. Okay, of course it might happen in many countries, but the challenge is huge in our case. Okay, let's say milk has to travel 8 hours in a day, and milk, is a perishable item, or meat has to travel from one city to another city, and it's a perishable item. And if the hygiene conditions inside is not right, and suddenly, let's say, the driver want to save the fuel, he will switch off the air condition and he will drive it, and maybe he is switching off the on the air condition before he reaching. So he want to save 1 liter of diesel, but he don't realize the harm he is creating for the food inside the truck, because he compromised the air condition. For him it's okay, but the food become poison, or food is not in the right quality. So who is monitoring? What is the solution to monitor it? There will be opportunity for us to find a simple solutions to monitor, and give a right indication and right control mechanism to stop it. Okay, let's say a food truck is going in a road, and assume there is a national natural calamity, some rain come or something come, and the road is not right. And if you simply give him some like a Google Maps, it's helping a way. I want to go, what is the fastest route? Okay, thanks to Google I will find. What if I stuck up in between? So how can IoT solutions can help? Hey, a particular truck which is carrying a perishable goods stuck up in a huge traffic or in a huge natural calamity, and we need to go and quickly offload it, or do some alternate route, or guide the driver in a right way. So these are the problems that we face, and people take it and they live with that problems. Instead of living with that problems, there are simplified solutions that we can bring, and help these guys, and together we can make the better life for all of us. Okay, so some examples. So we all improve the quality, and we'll help the end-to-end tracking, and obviously it will be more efficient optimization, and better compliance. Better compliance means the food obviously has to be compliant. The food, let's say you are supposed to get a milk with a pH value of 6.5, but are we sure, are we getting a milk with 6.5? Is it not too acidic with 7, or is it to someone is adding some salt to make it less pH? So these are the issues we can solve. Okay, and okay, I have 5 more minutes. And look at the scenarios. Agriculture, okay, not every state have the same problem, but different states have a different problem. So sometimes there is no rain on time, or predictability, or the moisture content in the in the paddy, or the storage conditions, or the soil conditions, the soil nutrition conditions, plenty. And most of our experienced farmers, they only rely on their experience. They assume, they get some assumption, and the knowledge transferred from ancestors and practices and neighbors. But can we augment them with the real sensor data, and really sense the moisture content in the soil, and give him, hey, this much moisture is in your ground, and you don't need to water extra, or you don't you it's a time for you to water it. Otherwise they just water because water is available, or there is soil nutrition nobody checks, and they simply put fertilizers because it's a fertilizing time. Whether the ground really need fertilizer or not, they don't know, they don't care. Okay, so before making the harvest, is that harvest ready? Their own experience, okay, everybody is doing, let me also do. But is the really crop ready for harvesting? They are not scientifically checking. So there are a lot of opportunities for to augment them with some sensors. Hey, okay, the crop still have moisture, don't cut it, wait 2 more days. Okay, or there are plenty of innovative ideas we can solve by simple IoT solutions. And I think the research from the universities has a lot of scope to solve these ground reality issues, in my opinion, or my suggestion. Okay, so with that, um, okay, the benefits of solving the agricultural issues. Obviously, the farmer get more yield, more profit, because the India is such a big country with agricultural backbone, and they are still not making profit. Okay, improved consistency year on year. They produce a good consistency crop, and informed decisions. Okay, if we inform, and hey, tomorrow is going to rain, don't cut it, leave it, or in next 2 days there is a chances of getting rain, better you cut it and store it in a right conditions. These informed decisions we can tell them, so that they don't get surprises and they don't get harm. Okay, or same, don't fertile, your land is already fertile, don't unnecessarily put fertilizers. The informed decisions can be done.
Sure.
Okay, so that's it. And about the agriculture opportunities, I have 2 more minutes. Let me explain what is Schneider doing in this world of IoT and Internet of Things, and Industry 4.0, the transformation. So Schneider, globally, we have come up with the 6 IoT architectures. One architecture called a EcoStructure building, targeting for the buildings. It can be residential building or commercial buildings. EcoStructure IT, EcoStructure IT is primarily for the large scale data centers and hyperscale data centers. And EcoStructure plant is primarily the industrial automation manufacturing plants. And the EcoStructure power is to make this power distribution IoT ready and IoT compliant. EcoStructure grid is the IoT based architecture for the utilities and substation, medium voltage substations. And EcoStructure machine is to make these machines smart and capable of operating with the digital twins of the machine. So these 6 IoT architectures is what Schneider is proposing to our customers. And they are all based on a simple architecture, like a 3-layer architecture we call, which is based out of the connected products and the edge control device. Because sometimes the connected products can directly talk to the cloud, sometimes they cannot directly talk to the cloud, so they go and talk to edge control device, and on edge control device will talk to the cloud. So what is this cloud is to run the applications, analytics and services. Okay, and this cloud can be in our architecture a public cloud like Amazon or AWS or Google Cloud, or it can be in-house in the factory. A private small cloud can also be imagined in a small factory, because of the nuclear facility. Nobody want to connect a nuclear facility to the cloud. There's a pharma industry. Nobody want to connect a vaccine making factory to the cloud, because of the compliance, because of the cybersecurity norms. So in that case, they want to have a local cloud. Okay, so and where do we operate? We operate in primarily for business domains. One is the buildings domain, or a market, I say, data center market, industry market. Industry means all the discrete and process automation related, and infrastructures. So these are our markets, and this is the 3-layer architecture, and we have 6 architectures to support this IoT needs of the customers. So what purpose? So connect the devices, connect the machines, connect the process, connect the people, and collect the data. Okay, and once we collect the data, and we need to analyze and take a right decision to optimize, to improve, to predict and prevent any faults that comes in future. So this is the what we do in the IoT world. So with that, I am on time. I take one more extra, 2:46. Thank you so much for listening to me. And now I'm open for questions.
Thank you, Virendra, for a very excellent presentation. Really touching upon many aspects of industry-related automation by IoT. So we are very happy you have uh, actually brought into what kind of applications are there for industry-related things. And also, I'm very happy that you have a very very much concern about the research that is happening in academia side. So you have touched upon what are the things that we can take it up and do as a part of our research. Thank you so much. I think there are a lot of questions that's there in the chat box. I just call upon uh, some, I think.
Any volunteer can read the
Yeah,
question
yeah,
so
yes,
that I
yes,
can answer.
yes, yes. Emma, can you just read out the questions so
Yes, sir,
that,
sure, sir.
yeah, yeah, please. Yeah.
The first question is, could you please shed some light on research trends and challenges pertaining to IoT?
Okay, sure. If you have access to the standard bodies where you can get some new trends, maybe IEC is one standard body, especially for industries, or IEEE. Mostly universities are tied up with IEEE. So IEEE is also working on standardizing the IoT protocols, standardizing the IoT connectivity. So with a lot of augmenting with research, maybe you can, if you already have subscription, good. Otherwise, see, a university might have some subscription to IEEE and study what is happening IEEE, the IoT related research. And outside, offline, I can connect to your coordinator who is coordinating this. I will share some URL links where you can find the latest trends and research in the IoT. Definitely, yes.
The second question is, what is the difference between remote access to virtual machine access in IoT?
Okay, so remote access, before IoT world, we used to have a remote word as popular, remotely connecting, remotely monitoring, all that. The remote monitoring or remote maintenance, they are basically you connect to a device through internet and read some data or open a web page of the device. So you read the device status, device information remotely. Okay, and sometimes you can download a file into a remote device. The file can be an application or a firmware. That's only. When it comes to IoT, what I said, the digital twin is, it's not just remote. You are creating the virtualizing the device completely into the cloud, and you connect to this device, and you have everything on your desktop. So from your desktop, you can operate everything of that device. For remote monitoring, you just need to open a web page of the device, and the web page will pop up with the data and some graphics, the status. But if you want to really control, you want to operate, you want to get complete virtual experience of that device, it's multifolds to the remote monitoring. Okay, that's the difference. Let's say you are driving a car. Today we have a car simulator. Okay, assume you are in a car simulator, you are simulating, you are driving, but with that there is a real car linked to it and it actually going. Okay, so you sit in a car simulator, you drive it, but there is a real car that is going whatever you are driving in the simulator. So that is the virtual.
The next question is IoT a substitute for M2M?
Okay, M2M, okay. Before IoT, we used to call M2M, which is called a machine to machine. These two machines are interconnected so that data can be exchanged from machine one to machine two, or a machine to your laptop is also considered as a machine in the M2M. So your laptop is connected to a remote machine. So the purpose of machine to machine is again only for remote connectivity, remote maintenance, and remote monitoring. Okay, but here IoT is more than M2M. So M2M is only a part of the IoT. It is not substitute.
The next question is, what is machine prognosis? What is the role of IoT in this area?
Machine prognosis. It's can you educate me the full meaning of machine prognosis? I'm not sure if I'm aware of it. Maybe I should Google it.
Can the person who posted the question please unmute yourself and clarify the question? I think there is some technical difficulty. We'll move on to the next question. Is there any
I
difference?
just need to understand the meaning of prognosis. Maybe I'm sorry, my vocabulary is not to your mark. But once I understand machine prognosis, I'll answer you. Okay. Then let's go to the next question.
Okay, is there any difference between IIoT and artificial intelligence?
There are
If
plenty of difference. There are plenty. They are not same. Okay. They are totally different. IoT is what I explained. IoT and IoT is basically the same, conceptually same. IoT is in general we call, but if you apply IoT concepts in an industry specific scenario, it is industrial Internet of Things, because industry has a lot of constraints, lot of system and a lot of regulatory compliance. The world of industry is different. The world at your home or in a hospital or in a airport, these are different. Okay, so IoT and IoT in principle it's the same. Okay, now artificial intelligence. Artificial intelligence is you are making the dummy devices think. Okay, simple example, you have an occupancy sensor in a room. Okay, and when you enter into the room, the occupancy sensor will detect it and it will switch on the light. So it's having a little intelligence to think, okay, whether the person has come or not. This is very little of intelligence. And you make your okay, most of you in these areas, I'm sure you have a subscription to Amazon Prime or subscription to Netflix, or you have Android. Okay, based on your viewing experience, based on your what channels you browse, or based on WhatsApp, what kind of applications you are downloading, either Google Play or your Netflix, they will try to come up with some suggestions. And who is there is nobody listening and looking at your subscription details. The algorithms will understand you and try to personalize and give you. The algorithm is applying some human intelligence. Say, okay, X person always watches sports, so he is famous of some Virat Kohli, so let me suggest more things about him. So this is what artificial intelligence. It comes to a machine is troubled. Let's say it has observed itself, the gearbox is getting damaged, or the machine observed some vibration. So if you put some artificial intelligence, he say that, hey, you know what, you are running me without looking at my gearbox for almost 10 days and observing some vibration. Maybe it's time for you to repair this gearbox. Maybe it's time for you to look at some fixing the components. So you are putting some intelligence. Okay, artificial intelligence is making the dummy device to think more, but IoT is connecting them. Unless you use both of them, you get real value of it. So for industry 4.0, the IoT and artificial intelligence is what it makes the fully IoT 4.0 story. Otherwise it cannot be done.
Next question is, in planned automation, security and integrity of devices is extremely important for applications like, say, boiler control. Can IoT really be put into service in mission critical apps at present?
Yes, we can. So this is where, in general, IoT in our home segment or residential or cinema halls or the theaters, this is different. When it comes to factories, there are a lot of regulations and a lot of cybersecurity compliances. So when we apply the IoT in industry, which we call as industrial IoT, yes, we can still monitor the boiler pressure, boil temperature, and the coal input inside, and the conditions of the boiler, and oxygen supply, all that we can still monitor with the IoT solutions and take control it. But the IoT solutions that we deploy in industry has to comply the industry standards of cybersecurity, industry standards of reliability. Suddenly the oxygen supply increase increased, and if you are not controlling, because it has to be controlled less than 20 milliseconds, otherwise the boiler will blow off. Okay, and you click some control button, and the command takes on the internet latency, the command reaches after 2 seconds, you are already late. So it has to be applied with a deterministic network, the network performance, and the reliable system, and cyber security compliant. As long as these are maintained and they are applied, and most of these years, the remote operations or remote monitoring is very conservative in the industry because of these fear factors. But the corona made everybody realize that's only way. Do you think in corona time all the factories are running with all the people in the factories? No. Many factories, we still need food, we still need electricity. We cannot sit at home because of corona, and we will not get food. So how the world food supply is managed? How the world the medicine supply is managed without the people in the factory? Because the digitization is enabling all this. Okay, so one side is the our mental capacity to accept, yes, this works, it is really a new technology is ready. Second is that apply with the right reliability rules, right, apply cyber security rules, and the right platforms. If you ensure, it will happen. But still some areas we are still maturing. IoT, I won't say it's 100% ready, you can apply everywhere and anywhere. It is definitely maturing, and there are readily available solutions, but this is not end of it. There are some areas where we cannot simply there yet. For example, you cannot operate nuclear plant today remotely, or a thermal power plant you cannot operate remotely 100%. We are still not there yet, but we are going.
The next question is, what type of exposure is needed in service oriented manufacturing? How to be an expert in such industries? Suggest a few certificate programs for learning automation.
Okay, service oriented manufacturing is evolving. As I said, this is the future, and probably maybe in our lifetime we should be able to see the speed at which it is going, or by your by the time you get your next generation kids. But this is what is really emerging. But today, do we have certification programming? No. This is the industry trend, this is what the world is moving towards. There is no certification. Okay, and we all have to make it together. And what is the exposure required is application of the IoT, application of artificial intelligence, because the artificial intelligence is only you are leaving hundreds of machines across the world and letting them to talk to each other, and deciding, okay, tomorrow I'm going to get a part A from Germany and part B from Japan. I have to integrate, and the customer A asked a red color paint with his name. So these are all happens with the artificial intelligence and right information aggregation. So this kind of knowledge is required for a collaborative and service oriented manufacturing.
The next question is, please suggest some tools of IoT for student and simulation based.
Tools for IoT student. If you are referring some software tools, see, there are no specific tools for IoT. Basically, you make the connected devices. A device connected means either a device intelligence gets connected to a cloud, or you put certain sensors in a device. Let's say you have a device of a CNC machine. You call device a CNC machine, or in your college you have a laboratory equipment, and the equipment is an electromechanical equipment, so it cannot be connected. So you augment the electromechanical equipment with some sensors, and the sensors will produce some data. And you need an embedded device which can read the data of the sensors and communicate the data to your mobile, or to your cloud using a Wi-Fi network or any other network. So you need an embedded programming skills, the tools required for embedded programming, and C compilers for. So these are the things. Otherwise, there is no one tool say, okay, this is the tool for IoT. It doesn't make any sense. Definitely, to flourish in IoT, you need to, there are two things. One is at the field level. For the field level, understanding the sensors, understanding the data aggregation, understanding the edge device and protocols, and that is one knowledge. another knowledge is that once the data is collected on the cloud, you are an cloud architect. You want to become, or you want to become a visualization expert. So you develop some Angular JS based applications on web page to make some analytics, or you want to study some algorithms, the statistical algorithms to make some optimization models based on your statistical knowledge. So you can make some models based on Python or R or any other language, or you want to become an expert in the database to manage the IoT data. It's a vast world. So you need to choose where you want to be expert, or you want to be a generalist end to end. So based on that, you take a call.
Right. Emma, I think we have almost answered all the questions, right? Is there any
Yes,
other
sir. Yes.
question?
No, we are almost done.
Yeah, so I think this is the time to thank Veerendra. Um, Samir, could you summarize and thank the speaker?
Yes, sir. Uh, Virendra sir, I hope you remember our meeting during the hackathon just 2 years
Yeah.
back.
I don't see your face.
Yeah, I'll
Are
just,
you on?
yeah. So,
Yeah. Okay. Mm.
so it was 2 years back. We met at Hubli.
Yeah.
So it's actually very nice to see you again,
Thank
and
you.
very happy to have you participate in our FDP. So I'll take the privilege of thanking you and closing this session.
Sure.
So in fact, your presentation was very enlightening. Especially you talked about the industry perspective, especially automation, and you also gave us an idea of cyber twin, basically the digital twin. Many people actually ask questions about the digital twin and like how it is connected to IoT. And in fact, gave us an idea about the cyber twin and what exactly it is. And I think your presentation was quite enlightening. The second part, especially, where you actually asked the people, the faculty, to come up and solve problems which are actually very much in need of the hour, and how you can do it. So I think the faculty here would be really pleased to have, very happy to hear the second session, which was quite motivating as well. And I hope they will take this message, and definitely they'll come up with something after this FTP. So
Sure.
on behalf of the organizers as well as the faculty participating, I would like to thank you for
You're welcome.
taking this session. And I also hope that we will see soon and with
Sure.
more collaboration,
Yeah.
and also in future talks where we can have more knowledge shared from you, especially
Sure.
in the industry. So
Sure.
thank you, sir. Thank you so much.
Thank you. See you all.
Thank you.
Bye bye.
Yeah, thank you, Virendra. Just one question. Would you
Sure.
be sharing the PPT to the participants? Just,
Yeah. Certain parts I will declassify
yeah,
and share it to you.
yeah, yeah, please edit and if possible, just mail
Okay.
me
Sure.
so that I can share it with the participants because they were asking for PowerPoint presentation.
Sure. Sure.
Yeah. Thank you.
Yeah.
Thank you so much.
Bye.
Yeah.